Okay, this is Module 3. This is for printed circuit board requirements. This is same as any other module that we study in IPC classes. This is so you understand the requirements that are laid out in the module and the relevant sections. For this module, section 9, 10, and 11 are covered. So 9 is for printed circuit boards, 10 is for coating, encapsulation, and staking, and section 11 is witness stripe, which is also called torque stripe or witness seal. So section 9. Section 9.1.1 is blistering and delamination. Blistering or delamination shall not exceed 25% of the distance or reduce the space between conductive patterns. So these are your conductive patterns. Let me get my, see if I have another color here. So these are your conductive patterns right here. These are conductive patterns. They shall not reduce and shall not exceed 25% of the distance between conductors or reduce the space between conductive patterns to less than the minimum electrical clearance. Like this example right here, this little bubble right here. This is a blister or delamination where there's a bubble, probably of like air in between the layers, the top layer and the underneath, the layers underneath in the circuit board. This would probably be acceptable, but an eye would need to be kept on this to make sure it didn't spread, because it says blisters or delamination areas may propagate. That's what that means. That may spread. This may grow larger, or another blister may pop up because this is already, that layer is already, it's, I wouldn't say damaged, but it's, put at risk. It's been compromised is the word actually that I'm looking for. So other blisters may happen here. So if this was any closer to one of these, or, bridged these two areas, that would be a defect. But as it is right now, it is actually technically not a defect. 9.1.2, weave exposure and cut fibers. Weave exposure shall not reduce the clearance between non-common conductive patterns to less than the minimum electrical clearance. There shall be no surface damage that cuts into laminate fibers. So if there's just like a scrape on the top, that that's something that would need to be looked at, that can be repaired. But if it or it could be used as is, but if there is surface damage that cuts into laminate fibers, that's what, if it's underneath, it's like there's almost like fiberglass, that would be we'd have frayed edges, that would be a defect. Haloing 9.1.3. Haloing is this right here where I see where it's lighter. It's like a little halo, right? Right here, yeah. Haloing is very common around the edges of drilled holes. So like this was put in there, by design, that hole, and the haloing can occur from that drilling action, or from being depanelized. So when the board is removed from the material the board is made out of, this can happen. The distance between the haloing penetration and the nearest conductive feature shall not be less than minimum lateral conductor spacing, or 0.1 millimeters. That's a very, very small amount. So right here, as long as this is greater than 0.1 millimeters, and it is determined that it is not less than the minimum lateral conductor spacing, again, that's something that engineering would determine, that would actually be okay. But an eye would have to be kept on this, because this can possibly spread. 9.1.4, edge delamination. So this is like before on 9.1.1, we're talking about blistering or delamination. This is a little different because this is an edge. This is probably from being depanelized. Probably the best way for me to describe what depanelization is if you ever built model airplanes as a kid, and they have those plastic parts that are all on like that one like plastic piece, and you pop them out. That's kind of what depanelization is. And these boards are made on one large piece of the layered, the laminate with the substrate, the fiberglass, and everything. and it's just one large piece basically of circuit board material, and they're popped out. They're cut out and they're popped out. And sometimes when that happens, this kind of thing can happen. These little bubbles here. The edge delamination shall not reduce the physical spacing to less than the specified minimum distance. Again, that's an engineering determination. Your work instructions would call that out. And that shall not reduce the physical spacing from the edge to the closest conductor. So this would actually probably be a defect because that's coming really, really close to that conductor there. If no distance is specified, the distance shall not be reduced by more than 50% or 2.5 millimeters. That's got to be at least 50%. I'd say that's actually greater than 50%, maybe a little bit over, but that is more than 50%. That would be a defect. Outer lower ledge of land shall not be lifted more than the land thickness. So the land is the little metal or foil area that we actually solder to. So this is lifted. So this is what it's supposed to look like. It's this little metallic layer that is attached securely to the board. This one is lifted right here. Let me get my better color here. I'll use my yellow. So right here, I'm going to go thicker so I see a little better. So right here, nope, I'm going to get a little thicker. There we go. So right there, that edge lifted. And then right here, the edge is, so this is a lifted conductor. So like right here, this is the conductor. It's also, you'll hear me refer to it as a trace. So that's showing a lifted conductor. The outer lower edge of land shall not be lifted more than the land thickness. So basically, if it's lifted at all, it's probably a defect because these lands are very, very, very thin. For Class 3 assemblies, surface mount technology land areas shall not be lifted when there's a via in the land. Let me see. I think one of these pictures showed what a via is. This is a via. These little holes right there. If there's one of these, there's like a via. If there's one of those in the land, let me see if there's a picture of that. That shall not be lifted at all. There shall not be separation of the circuit conductor or the trace, which is what you'll hear me refer to it as, from the laminate surface. So this would be a defect. The width or printed conductors or width length of lands shall not be reduced by more than 20% for Class 2 and 3 or 30% for Class 1. So this is at least, I'd say at least half, maybe 40%. This is almost completely reduced. So these would both be defects for all three classes. Delamination or bubbles in the cover layer, so that top layer, of the flexible circuitry. So this is flexible circuitry delamination. Sorry, I forgot to mention the chapter here. It's 9.1.6 and 9.1.7. Delamination or bubbles in the cover layer of the flexible circuitry shall not span more than 25% of the distance between adjacent conductive patterns. So flexible circuitry, you may see this like inside a computer, like a computer tower, on those the cables. Those delamination or bubbles shall not span more than 25% of the distance. I do want to kind of highlight this because you may see this in a test, so please keep note of that. I've seen that question on tests a few times. Flexible circuitry damage, this is another one that there's often questions on in the test that does throw some people off. There shall not be evidence of tearing, blistering, charring, or melting of the insulation. Flexible portions of the circuit cards shall not exhibit cuts, gouges, or tears. Nicks or imperfections shall not exceed 50% of the distance from the edge to the nearest conductor, or 2.5 millimeters. So, like, this is showing, I believe, like a cut. This is kind of it's so hard to see, but this is like showing like a cut in this. Like this is meant to be here, but like this is not, or something. I'm not sure. It's kind of weird. I'm not really sure what that picture's showing us, but you may see this picture on a test. This is showing, this is more of an obvious cut right there. 9.1.9 and 9.1.10. So burns and non-soldered edge contacts. Burns shall not physically damage the surface of the assembly. This is physically damaged assembly. That's a pretty bad burn. When you first start soldering, you may have some discoloration on your board. If you can clean it off, that's not a burn. That's just discoloration. It's probably a little bit of a, it's just a reaction caused by overheated, flux, or overheated conformal coating, or something else that's on the board. If it can be cleaned off, it's not considered a burn. This would not be able to be cleaned off. That is completely damaged. The contact area of edge connector contact lands. So this is for a connector, and this is not supposed to have solder on it. This shall be free of solder, flux, and other contaminants. This would be a defect for all three classes. That is considered FOD. Measles, 9.1.11 and 9.1.2 is called crazing. So that is crazing right here, this little hatch pattern right here, and then this is measles, these little bumps. Measling, they're almost like very, very tiny blisters, but they don't go as deep, and they're very, very small. They're like freckles, or like measles. So measling shall not exceed 50% of the conductor spacing. Crazing shall not exceed 50% of the conductor spacing. So this this crazing here, this would be a defect. I don't know if these would be. I mean, this might be, because it is a lot. Crazing shall not reduce the board edge to conductor spacing below specified minimum, and it does here because it goes all the way to the board, all the way to the conductor. If minimum is not specified, minimum reduction. If minimum is not specified, reduction shall not be greater than 50% or 2.5 millimeters. So this would be a defect. I don't know honestly if this would be. While measling is not a defect, it would be, I think, more of a process indicator. I don't have my book in front of me. Measling is an internal condition. The difference between measling and blisters is that measling won't spread like a blister might, or delamination might. Delamination is a condition that, since it could grow under some sort of stress or thermal stress, but measling is not like that. It's more of it's more of just a surface level defect, a cosmetic defect, if you will. Markings should remain legible, and components mounted so that markings are visible. So this is section 9.2. Part numbers and serial numbers shall remain legible after all tests, cleaning, and other processes. Additional markings should not obscure the original supplier's markings. So for like part numbers, any kind of markings that you put on as the end user or in preparation for the end user should not violate kind of like original supplier's markings, like if they have lot numbers, part numbers, or anything like that. Bow and twist should not exceed 1.5% for plated through hole and 0.75 for surface mount technology. And your key word here is should not. Okay, that is a should not. That is not a requirement. It is highly suggested, but it is not required. Testing may be necessary to confirm that the bow and twist will not result in solder connection failure. So it may have a little bit of a warp to it. So you see how it's not perfectly straight. It may have a little bit of a warpage. As long as it's not going to affect the fit, form, or function of that board, it would not be considered a defect. It wouldn't, yeah. So this in and of itself, the warpage is not considered a defect. So if it did affect the fit, form, or function, it would be, because it should not affect the fit, form, or function. Once it does, then it becomes a defect. So depanelization. So we're talking about depanelization again. Depaneling shall not damage the assembly in excess of the following. Edges shall not be frayed. I want you to remember that too. Yet maybe something you see on a test. Nicks or routing shall not exceed 50% of the distance board edge to nearest conductor, or 2.5 millimeters, whichever is less. Loose burrs shall not affect fit, form, or function. Okay, so we're doing the Module 3, Section 9 review. On Class 3 assembly, there is a 25% reduction in printed circuit conductor width. This condition is, so I want you to take a minute to go ahead and look in your PDF, or even back through this this one. I'm going to give you a couple seconds. I will give you a hint. It is in 9.1.6. Okay, so go to 9.1.6, and it is a defect. Because it's class 3. I think for class 1 is 30%, class 2 and 3 is 20%. Bow and twist after surface mount technology soldering measures 0.80%. Testing has determined that bow and twist has not created stress that will result in solder connection fracture, component damage, or will otherwise cause damage during post-solder assembly operations or use. So remember what I said about this, about bow and twist. It shall not. So it's 0.75%, and it's a little bit greater than that. It's at 0.8, but remember, it shall not. It doesn't, the bow and twist does not create a stress. So let's see, I will give you, so that is in section 9.3. What was 9.3? And that would be considered acceptable because it's a shall not a should not. Crazing that has occurred on 55% of the physical spacing between conductors. So that is section 9.1.2. I remember something about 50%, something about you can't be greater than 50%. So if we go back to section 9.1. I'm sorry, not 9.1.2, 9.1.12. My apologies. 9.1.12. We're going to see that is a defect for class 3. A bubble in the cover layer of flexible circuitry that expands 20% of the distance between adjacent conductive patterns. So they're next to each other. That's what adjacent means. It means that the two patterns that are conducting a signal are next to each other. There is a bubble in the cover layer of the flexible circuitry, and it spans 20% of the distance. Now you want to look at clause 9.1.7. Okay. Go to 9.1.7. Now, if this was a question I was doing on a test, I would probably search for the word cover layer. And it would, because there may be a few examples of the word bubble, but cover layer isn't as frequently mentioned. So that's like if I were to do this on a test, I would look at the word cover layer. And that brings us to A. So it is not requirement. There's no requirement established for class 1, and that would be acceptable for class 2 and 3. I believe the number was supposed to be 25%. I think it's 25%. Or it's a shall. I don't know, or should. After depanelization, board edges that are slightly frayed. So now that was something I just discussed about depanelization. So that's in section 9.4. Board edges that are slightly frayed, just a little tiny bit. Well, I'm going to tell you something. There is a requirement established because it was not a should not. So we know it's not this. This is a good example of one that you can use process, or you can use a process of elimination. There is nothing that's going to be a process indicator for all three. So we notice that. Slightly frayed. I don't know. We have to look it up. So you have to look. So it's like, would it be? Either way, it would be acceptable for all three or a defect for all three. So you'd want to look that up. Go to section 9.4, and you will see that as a defect because it shouldn't be frayed at all. Slightly frayed, horribly frayed, it doesn't matter. It shall not be frayed at all.